All right, welcome. So you've definitely had this happen. An application you're using just dies. Gone. Well, today, we're going to put on our detective hats and solve one of the most common and critical mysteries in the tech world. Why our applications suddenly crash.
I mean, we've all been there, right? You're deep in your work, maybe you're in the middle of a game, and then poof, the application just vanishes. It's not slow, it's not frozen, it's just completely gone. What is going on there?
To solve this mystery, first we've got to figure out what kind of crime we're even dealing with. If your app is just being slow, kind of laggy, and unresponsive, the evidence usually points to the CPU, the processor. But when it's crashing completely, that's when we're looking at a totally different culprit, a memory issue.
Okay, so let's get into it. We're dealing with a full-blown memory problem here. And our prime suspect? It's this stealthy, invisible thief that engineers call a memory leak.
Now here's the thing. When an application crashes like this, it's usually not some random accident. It's actually the deliberate work of a system process called the OMM killer. OMM stands for out of memory. Think of it like a security guard for your computer, making a tough call to take down one misbehaving app to save the entire system from going down with it.
So, to really understand how this memory thief operates, we've got to understand the crime scene itself, the computer's memory. Let's use a pretty simple analogy for this. Imagine you're renting a 3-bedroom apartment.
When an application starts up, it gets ambitious. It might only need a tiny bit of space right now, but it tells the operating system, hey, I might need this entire giant penthouse someday. This total requested amount is its virtual memory. It's really just a promise from the OS that, yeah, that space could be available if you need it. But the operating system is actually pretty smart. It gives the app the keys to the whole penthouse, but it only puts furniture in the one room it's currently using. This physical, in-use memory is what we call resident memory. So you might have the whole apartment, but you're only really taking up space in the living room for now. Now, in a healthy system, an application's memory needs are always changing. If it needs more memory, say to move into a bigger room, it gets it from a big pool of memory called the heap. And when it needs less, this amazing little process called the garbage collector comes in and tidies everything up, freeing any memory that's no longer being used.
And this is where we start to see the hard evidence. If you were to graph the memory usage of a healthy app, you'd see this really cool up and down pattern. It looks just like the teeth of a saw. Memory gets used, then it gets cleaned up. Perfect. But with a leaking application, the graph tells a totally different story. The memory usage just climbs, and it never comes back down.
And that relentless upward climb, that, my friends, is our culprit, the memory leak. It's what happens when the program just keeps taking more and more memory from the heap, but for some reason, the garbage collector never cleans it up. The application just keeps hoarding all this memory it doesn't even need anymore.
So, we have a suspect, we have a pattern of behavior. How do we get that final conclusive proof? Well, we perform a really high-stakes interrogation technique on the application. It's called a heap dump.
Just think of it like a forensic snapshot of the application's memory. A crime scene photo, basically. It captures this complete, incredibly detailed picture of everything, every single object that's living inside the application's memory at that exact moment. It shows us precisely what's taking up all that space.
But, and this is a big but, this is an extremely delicate and pretty dangerous procedure. Taking a heap dump can freeze the application solid, sometimes for a really long time. And the file it creates can be absolutely enormous. We're talking over 50 gigabytes sometimes. This is exactly why it's a last resort, and it's something that only specialists should ever handle.
So this is it, the final step in our investigation. The specialist developer takes this massive heap dump file and starts analyzing it, digging through to find out exactly which objects are hogging all the memory and, this is the important part, why they aren't being cleaned up by the garbage collector. And the analysis basically confirms what that graph was telling us. If the data shows that beautiful sawtooth pattern of memory being used and then released, the system is healthy, case closed. But if it confirms that steady, incremental climb, we've found our smoking gun, a confirmed memory leak.
So, here's the crucial point of all of this. The problem was never a lack of memory. The real villain here is a bug, a mistake in the application's code. The programmer wrote the code to take memory, but they forgot to write the part that gives it back. That's why just adding more RAM to the server doesn't fix it. You're just giving the thief a bigger house to fill up. It only delays the inevitable crash.
And that kind of leaves us with a fascinating and maybe slightly scary thought, doesn't it? If a single tiny coding oversight can cause so much chaos and bring down a whole application,
It really makes you wonder what other hidden flaws are just lurking beneath the surface of the complex digital world we rely on every single day.